Hi, welcome to model problem number 2 for two-step mole conversion. So this problem asks how many grams are there in 683 milliliters of CO2 gas at STP. So what information am I given and what am I asked to find here is my first step. So I'm given the volume in milliliters. So remember, units for volume are liters or milliliters. So this is volume. They're telling me it's a gas. Okay, and it's at STP. So in terms of the information that I'm given, I'm starting over here with some gas information. So I have the volume, and I know it's at standard temperature and pressure. The next thing that I'm asked to find, what I'm asked to find here is how many grams. So grams, unit for grams, grams is a unit of mass, so that means I'm trying to find the mass. So my plan, what I'm going to do is I'm going to go from my ideal gas information to moles, and then from moles to mass. So that's the plan that I'm mapping out. Okay, so here we go. So this is my plan. Now that I have my plan, what I'm going to do is I'm first going to show you how to solve this using equations. So I'm starting over here. That means the first equation I'm going to use, let me just zoom this in real quick so you can see a little bit better, is the PV equals nRT equation. That's the first equation I'm going to use. So that means I need to get as many variables as I can, or values as I can, to plug into this equation. One of them is going to be my unknown. That's going to be moles. I'm always going to solve for moles first. But that must mean I must have the pressure, the volume, the temperature, and R, of course, is a constant, so I definitely have that. So I need to figure out what all the things I have from the problem, okay? So let's get started on that step. So the equation I'm using is PV equals nRT, and let's just sort of walk through what our information here. So let's start with pressure. They're telling me it's at STP. Now remember, STP stands for standard temperature and pressure. So that means that the pressure here is 1 atmosphere, because that's the standard pressure. And then the standard temperature is 0 degrees Celsius, which is the same as 273 Kelvin. Because remember, you take degrees Celsius plus 273, and that gives you the value in Kelvin. Now for my volume, the other information I have here is my volume, but it's in milliliters. So I'm going to convert that to liters. Remember, your volume must be in liters. So we're going to do 683, divided by 1,000. And that gives me 0.683 liters. So I have my pressure, I have my temperature, I have my volume. Perfect. I have all these values. And I'm looking for my moles. So this is my information here. So what I'm going to do is I'm just going to plug these values into my PV equals nRT equation. Remember, N is your moles. So go ahead and take a moment to plug that in. Leave N as your unknown, so that won't have a number. Okay, so when you've plugged that into the equation, you should have this, okay? And now what we're going to do is we're going to solve. So to isolate our unknown, we're going to try and combine as many like terms as we can on one side, and then isolate it. So on this side, I'm just going to multiply 1 times 0.683, and that's just 0.683. And over here, I'm going to multiply 0.0821 times 273. And that gives me this value here, 22.4. Now I need to further isolate my unknown, and I'm going to do that by dividing both sides by 22.4. Okay, and then when I do that, I get my moles is equal to 0.683 divided by 22.4, which is 0.03049 moles. And remember, I have one additional significant figure here, just because this is not my final answer. Okay, now that we've converted from our volume of our gas at STP to our moles, the next step is to convert from moles to mass. And so for that, we're going to use this equation, moles equals mass over molar mass, right? So you can go from moles to mass, you use this equation. Now, to use that equation, I need to, of course, get the molar mass of CO2, which is the gas I'm looking at. And this I get from the periodic table. So here's the work I did to get my molar mass. Now what I'm going to do that I have my molar mass is plug in my values. So my moles, which I got from the previous step, goes there, and my molar mass goes in there. So take a moment to plug these in and see if you can solve for the moles. So if you need to, go ahead and pause the video. Sorry, not moles, solve for mass. You're solving for mass now. So plug your information in and see if you can solve for mass. And when you press play again, I'll show you my work. Okay, so this is the work that we have here when I've plugged everything in. To solve for my mass, remember I have a fraction next to an equal sign, so I'm going to use cross multiplication, and that gives me my mass is going to be equal to 0.03049 times 42.01, and that gives me a mass of 1.28 grams. Okay, so we've seen how to do that here, but what about using dimensional analysis to do it? Now, remember, for dimensional analysis, you can really only use it when you have sort of a scalar quantities, right? Like if 1 mole is equal to or equivalent to another amount or value. But you can't do that with the PV equals nRT equation typically. However, if you are trying to find the volume of a gas at STP, or going from moles to volume of a gas at STP, you can use dimensional analysis, because 1 mole of a gas at STP occupies 22.4 liters. So we know that if you have 1 mole, the volume at STP, the volume of that gas will be 22.4 liters. If you have 2 moles, it'll be double that. If you have 5 moles, it'll be 5 times that amount. So this is a scalar quantity, so we can use that. So let's see what that looks like for this problem here. So for the dimensional analysis setup, volume of a gas at STP, that's what we're starting with. So we're going to convert that using this conversion factor. So I take my given 0.683 liters, I was given that volume, put it over 1 just to make it into a fraction, and then we're going to multiply it by our conversion factor. Now our conversion factor is going to come from that relationship, 1 mole is equal to 22.4 liters. Now remember, in order to set up our conversion factor properly, the units of our given, we want to cancel those out, so they must be in opposite position. So if I look here, I say, oh, there's liters there. Well, that liter has to go on the bottom, and then the 1 mole will go on the top, just so that we can make sure these units cancel out. Now what I have is, at this point I have the moles. So now I need to get to the grams, my mass, right? And so to do that, I'm going to use the conversion factor from the molar mass. 1 mole is equal to the molar mass in grams. And molar mass for CO2 is 42.01 grams. So I'm going to take this information and make it into a fraction. I want to get rid of moles now, so the 1 mole from this equation is going to go on the bottom, so it can be opposite, cancel out. And the 42.01 grams goes on top. All right, so then my units are great. I've canceled out all the units I don't want, and I'm left with units of gram, which is what I do want. And then I just need to do the math, which is 0.683 times 42.01 divided by 22.4. And that gives me a mass of 1.28 grams. Okay, so that is it for video for problem number 2. The next problem is problem 3.